Okay, let's start!
Everybody wants to be an ant. Crickets, mantids, my own father circa 2001, hemipterans, beetles, flies, phasmids, etc., etc. Why? Because ants are awesome? Yeah, definitely. But also probably because ants are unpalatable and aggressive. However, perhaps the true presidents of the ant fan club would be jumping spiders of the genus Myrmarachne. I mean, just look at these guys.
More than just physical appearances, these spiders will behave like the ants they mimic. It turns out they walk different from normal spiders. Instead of the typical looping, meandering paths that jumping spiders take, these mimics will go in the brash, continuous lines that ants would make along a foraging trail.
However, not all ants walk the same. There's a diverse array of different locomotory patterns among ants.
Strobe ants have this staccato start-stop movement pattern that makes them look like they're dancing under a strobe light. The stuttering you see here isn't because of a streaming video issue, it's actually their own weird movement patterns.
However, some Myrmarachne species have risen to the challenge. They mimic these crazy strobe ants. So my question is this: can these spider mimics keep pace? Do they move more like their cousins who mimic normal ants? Or can they change up their moves to fit the occasion? It is time for Ants Dance Evolution!
Time to introduce our contest ants. In one corner, setting a rapid-fire beat, is the strobe ant Opisthopsis hadeni. Her daring spider mimic over here is Myrmarachne bicolor. Representing the more typical ant movement patterns is Polyrhacus aurea, and her mimic is the ever-stylish Myrmarachne luctuosa. However, two other ant species were added to this study, Opisthopsis major and Camponotus bigenus. These ant species are a little bit bigger than the putative models here, but they're visually very similar. And since all of these species can be found on the same trees, we decided to include them in our study as well. To witness their sick moves, we simply let individuals loose in our cardboard stage and filmed them at 240 frames per second. We then digitized these for the rest of the analysis. Let's look at their speed over time, though.
Doubles play!
For the strobe ant, it is like a metronome on and off, and its mimic?
Perfect!
Nice! If we look at the black and gold group,
Versus play!
we'll see that the normal ant has a kind of continuous movement with irregular stops,
Those are the nicest steps!
and its mimic is pretty similar. It has a few pauses where it actually uses its forelegs and waves them around like antennae. Otherwise, it's great.
However, we need to quantify how strobe this movement is. So I used wavelet analysis to extract several different features from each individual's run. So first of all, we got the rhythmicity, which is kind of how rhythmic their speed over time is. Then we looked at the synchronicity, which is how all or nothing their movement was. We looked at the length of time from a start of a cycle to the end of a cycle. We looked at how straight their path was over time. And then the percentage of time that these ants and spiders were motionless. We got these features, we put them into a principal component analysis to better visualize how everything falls out.
If we look at our two strobe ants, we'll see that they're very similar, and their mimic is boing, right on target. But if we shift our attention to the normal ants, we'll see that there's a bigger spread, and their mimic is not quite as on track. However, this black and gold is actually a global mimicry ring, so there could be other ants not present here that kind of fill in that space. if we take the first component axis and do stats on that baby, we see, yes, there is similarity between the Strobe ants and between the Myrmarachne luxuosa and its model, as well as the two normal ant species. If a predator can't tell apart a tasty butterfly from a poisonous one, the mimic might live to see another day. Historically, such Batesian mimicry has been studied using static museum specimens. However, we know that perception is a dynamic process that often uses movement-based cues. To our knowledge, this is the first instance of a species-specific terrestrial locomotory mimicry that's been found. However, I'm sure there's tons more out there. We just gotta find it. There's some awesome antennal illusion behavior that I didn't get to cover, so go to my Q&A or my office hours afterwards, or just hit me up whenever.